Okay, we're back. We're live. This is ThinkTech, but you knew that. It's the 1 o'clock block. And we're talking about research in Manoa with Jeff Taylor and Linda Martell, old hands at ThinkTech. Welcome to the show, you guys.
Hi, Jay.
Good to be back.
Great to see you here. And you have news. You have news. First of all, this is a very fancy picture you brought about fireworks on the 4th of July. Can we see that?
Yeah, can we see it?
We're fans of fireworks, and there's also these cool images that NASA has out there to the public. And whenever I see these kinds of pictures, like from the Hubble Space Telescope and other telescopes, they always remind me of fireworks. So this one is actually from 5 different telescopes. They made a combined image, and it spans the whole electromagnetic spectrum. So it's visible light and radio frequency, and you can just see the dust, and the colors are gorgeous, and they always remind me of fireworks. So I thought, let's celebrate 4th of July holiday with a real natural picture from our own universe.
Beautiful, beautiful. Thank you for that, especially on the 4th of July.
Yeah.
So how do you do that with the Hubble telescope?
Well, this is 5 different ones, and I can't really name you all of them. They're in the credit there. It's Europe and NASA and various places. So the cool part is that it's all these different wavelengths of light giving us all different information on the composition of the dust. And it was made when a star exploded at the end of its lifetime. Now, the cool thing about that is when a star explodes, it releases elements. And it's the kind of elements that kind of plays into our theme today of when we talk later about space resources. Where did all those resources come from?
We're going to talk about that. But first, we're going to talk about the eclipse.
Total solar
eclipse.
eclipse.
That's Linda Martell. She's a researcher at HIGP and SOWEST at UH Manoa. Next to her is Dr. Jeff Taylor. He's a professor of
planetary science.
Of course, what would be more appropriate in HIGP at SOWEST at UH Manoa?
Well, some oceanography would be, we do it all and do it well.
I knew that, and now they do too. So let's talk about the eclipse. What do you got to show us on the eclipse?
We have, this is a picture we actually just found this morning. We found it because one of my office suite mates had it. And he had just seen it. It's a spectacular picture of an eclipse taken a couple of years ago by one of our colleagues and co-workers at Shadia Habo, who is in the Institute for Astronomy and is a solar expert. And this picture, here's what's so amazing about it. If you look carefully at it, you see all the swirls around it. And that's the solar corona, which is what is visible outside the diameter of the moon.
How is that created? Magnetism, gravity, something?
It's a combination of all that physics that happens inside the sun, from magnetism to convection of things. And it's spewing out all the time, including coming towards us. But the moon, see, you can see the moon on it. The moon's islands and dark areas are illuminated if you look carefully. That is illuminated by Earth shine.
Yes, because that's the dark side of the moon,
At this time, because it's passing in
Isn't
front of the
that
sun.
something?
Like
That's fabulous,
thing. And it gives you an idea that a full Earth, if you're living on the moon, you actually would have some light, but more brighter than the moon. A full moon is to us on the Earth. If you're out
We're a
there
bright planet, actually. We do reflect a certain amount of light.
Yeah.
And it's good to reflect light. You don't want to absorb it. You want to reflect it.
That's right. The
That's
heat.
the climate change.
Right. That's our clouds and our ozone layer are important, right? So that picture that showed the wispy, corona of the sun and all that energy coming out from the sun, when they just have a telescope, they can put a little block on the sun normally when there's not an eclipse to sort of study that temperature and everything going on with the sun, but they can't see all the way down to the surface of the sun. And that's why these eclipses are so important, because the moon is completely blocking out the sun's
So you can see the light from behind the moon, and you can see more that way than you could if you didn't have the moon blocking all the energy of the sun.
So the one coming up this year is August 21st.
August 21st is coming soon.
And it will be passing the continental U.S. We can't see it here, but from Oregon to South Carolina, I think it is.
Now, the remarkable thing is these guys, Jeff Taylor and Linda Martell, have some footage. They do this with some very high-tech, very high-science thing. they have some footage of what is going to happen on August 21st. You're going to have to tell me how you got that footage.
We have this important tool called Google. Have you heard about it?
We downloaded it from NASA.
Okay. Well, let's play it and see what it looks like. This is 1 minute of an eclipse, not this eclipse coming, but
this eclipse
previous
coming.
eclipse.
You'd have to have a time machine.
I would be very impressed if it was
That would
this
be
eclipse
cool,
coming.
wouldn't it?
That's right.
Yeah.
On August 21st, 2017, the Earth will cross the shadow of the Moon, creating a total solar eclipse. Eclipses happen about every 6 months, but this one is special. For the first time in almost 40 years, the path of the Moon's shadow passes through the continental United States. Everyone there will see the Moon at least partially block the Sun. People within the path of totality, shown here in red, will witness a total solar eclipse. For them, the Moon will cover the Sun entirely. The sky will become twilight, the air will cool, the stars will appear, and the black disk of the Moon will be surrounded by the pale, streaming halo of the Sun's corona. Totality will last for 2 minutes or a little more, and it will be visible along a swath that crosses the continent, from Oregon to South Carolina. For some, it will be the spectacle of a lifetime.
Oh, from NASA.
NASA
The
has
spectacle of a
They have
lifetime.
a very good heliophysics program.
Yeah.
And that one is from Goddard's, that little video.
So what did that show us?
Basically, it shows the last part that really is the most pertinent, shows the path of the totality where you get the total eclipse. And if that line that diagonally went across the mainland U.S., right through Casper, Wyoming, for example, and then down through the midsection and exiting in the coast of North Carolina, and so it just shows a lot of people will be able to see this.
Yeah,
So-
right across the middle of the country.
Yeah.
And so what will they see exactly? Will it be like that earlier slide with the halo around the moon and
Yes, you can.
the
You
earth
can't-
shine onto
I
the
don't think
moon?
you'll be able to see it. I assume quite as the detail, because that was
Telescope.
in
Yeah, of course.
spectrographs and stuff.
Mhm.
But you will be able to see that, and you see this shiny spike coming out of the sun, and it does get dark, but it doesn't get the amount of light visible from the corona of the sun is sort of like a full moon's worth. So it doesn't apparently get pitch black. I've seen one, but it does get quite dark.
Yep.
And
What strikes me is that picture, assuming it's something like that, it's in the daytime.
Yeah, we're
You're
talking
looking at the sun. and The moon just
noon-ish.
happens to be blocking the sun.
Mhm.
So we would see that here in Hawaii.
No, we would see part of the sun block. I don't even know if we get to see any of it. But Denver, for example, about 150 miles south of Casper, Wyoming, is going to be 95% total. But then the further away you get from that path, the less you see.
Oh, how
And
interesting.
Hawaii, I think, will have none because it's coming from the north. So it'll be way north of us. So we won't see anything. But half is a significant reduction in sunlight, but it isn't this spectacular show that you get for 2 to 2.5 minutes only.
Is that all?
That's
Mhm.
all.
So what do I have to do to prepare? Do I need sunglasses? I shouldn't look directly at it, huh? Do I need a telescope?
No, there's all kinds of, and there's good websites for this, of where you can make your own eclipse viewer. There are little there are pinhole cameras you can make and project the eclipse down to a piece of white paper so that you get indirect light. And then once it's at total, you can look at it. The other thing you have to do is to book a flight to the mainland U.S.
Go to Casper.
Go to Casper.
I can see the crowds.
I was going to say, I think every room is booked, and for
To
all
see the
these
eclipse
places.
for 2.5 minutes.
Yes,
Yeah,
yes.
they have boosted the price.
Yes.
It's the way it works, like the gold rush.
Imagine it being noon, a regular noonday, and then it just goes dark, and the birds will be, all the animals will be quiet.
Are you wondering what's going on?
Hush, and then it'll be bright up again. Yeah.
Bright again.
But the scientists will be, tracking it the whole way, getting all that information.
You guys going to go?
No.
Okay.
Can't
You'll be
go.
watching from afar.
It's the first day of classes.
That's right.
Okay. Well, let's move to the principal topic of the show. And if I didn't mention it, the title of our discussion here today is New Planetary Space Resources. Ooh, we're talking about mining things. Can you tell us?
Yeah. Well, first, why do you need it? And one of the things, if you imagine like picture number 2 has, a thriving big colony on the moon where you're doing things. Well, you have to, here's a picture of it, you have to, it's critically important to mine materials you're going to use on the moon there. Because if you don't, you have to haul everything up from the Earth. And, we have this big gravity thing going on here, and it becomes wildly expensive. But if you can make them there through new technology and use of local materials, you live off the land. The ancient Hawaiians did not move here with a 10th century supply of food. So I think if we're going to do that, and there are good reasons for doing it too, for having a big base on the moon in preparation for, say, bases on Mars, places on the that have commerce in Earth, in near Earth space. I think some of the most important reasons are simply inspiration. You got to have something bigger than yourself, and like slide 3 shows two little kids next to something bigger than themselves.
Is that why?
The LA County Museum, and those are related to me, those small children, my grandchildren. And on the right is the opposite picture. So here's a parent explaining to his son or daughter where they came from at a lunar base sometime in the future. I love the little wagon filled with moon rocks at this place on the moon. And I think, though, it is really, young people need to dream, to inspire for something big. And this is such a magnificent challenge. And that's what we really want them to really grasp. And I think space exploration is one of those great things. The solar eclipse will be very cute to see it. We'll never forget it. They wonder, well, how this happened? All these kinds of events.
Asking those questions.
Yeah. And
one of the questions that we ask in this show, by the way, is it 15 minutes after the hour? We always ask that question. Because if it is, we take a break.
Stop talking?
Oh, no.
Oh, but it's only 14 on the clock.
Watch this.
Aloha, my name is Stephen Philip Katz. I'm a licensed marriage and family therapist, and I'm the host of Shrinkwrap Hawaii, where I talk to other shrinks. Did you ever want to get your head shrunk? Well, this is the best place to come to pick one. I've been doing this. We must have 60 shows with a whole bunch of shrinks that you can look at. I'm here on Tuesdays at 3 o'clock every other Tuesday. I hope you are too. Aloha.
Thank you. Kindness. Pass it on. A message from the Foundation for a Better...
Okay, we're back. We're live with Jeff Taylor and Linda Martell, and we're talking about space resources, finding them and mining them and why. Let's talk more about why.
If I have a little graphic in number 4 that shows a bunch of things, including a dangerous airplane. I think going to establish a base on the moon or have permanent habitation in the space between the Earth and the moon and Mars it just gives us a whole new perspective on how to solve the problem. If the lower right shows energy in the environment, you know what? I claim that the moon's environment is so fragile that everything you do to it could mess it up. So by living there in this environmentally conservative way, maybe we think of new ways to conserve the environment on the Earth, but also push the attitude that we ought to preserve the environment on the Earth. Because it is life and death.
It's pristine right now.
It's pristine now, and it's life or death. If you're living on the moon, to have the environment not get wrecked up, including if we mine it. We'll show a picture of a big pit mine on the moon, but the fact is, when we mine the moon, we'll have new techniques to do it because everything is so valuable, we won't waste a thing. And because it's also valuable. We don't want it to leak out into the environment and contaminate areas for other scientific studies. So it gives us a whole new way of looking at the world. But it's also broader than that. You know, there's a group of people who will be there, maybe from more than one nation, and they have to get along with each other.
Yeah.
And they will develop the attitude. They're doomed if they don't develop the attitude. How are we going to collaborate here and cooperate? And maybe that helps us understand conflict resolution on the Earth, and maybe use more words than bombs. And the same with government. You know, there's two pictures there, poverty and government. These are related. And because much of poverty is due to bad government or insufficient government. I mean, we complain about poverty as rightly in this country, but in other countries, it's really bad government. Well, there's going to be a little government develop up there, no matter how much ties we have to Earth government. And they will work together and get a whole new attitude. There's this whole perspective on
So what we learn up there, we should bring back here.
Yeah.
It's interesting. It's a pristine laboratory for learning. And those lessons cannot be lost, and could change the world if we pay attention.
You know, there's a little bit of that. I was just thinking, listening to him, going on now in Antarctica. It has a treaty, and every country that works there, we understand, we keep it pristine. It's for science. It's for understanding life better. Maybe that's a good. We should expand that idea.
Sure,
Yeah.
to the whole world.
So exploring for resources on some place like the moon, I feel like it involves the big picture thinkers and also the people who like details. Like it needs all of those kind of imaginations. And
we have to be careful. We have to use best practices, best thinking, best everything. It is a test of our best.
Yes.
Is what it is.
Yeah, isn't that right? Yeah.
And there are conflicting needs, but they work together sometimes, like science and resource exploration. Well, first of all, you wouldn't be able to know what you're looking for on the moon if we didn't have lunar samples and moon missions to be able to tell us where to go for certain things.
But what are we looking for on the moon?
Well, anything you need to build something. You got to have a house to live in.
So you build a building. So you're looking for building materials?
The building materials, and we know
Bricks, the kind of stuff that makes bricks?
So the dust, the regolith on the moon, if you heat that up, you could make great bricks and building materials right there out of that.
Okay, so it's what you were saying at the outset, that you don't want to bring it with you. It's too heavy and all that. So you have to have smart ways to use the materials that are right out there.
And maybe innovative agriculture. You're going to have to be at hot houses.
I saw that in the Martian movie.
Yeah.
That was very innovative.
That was very innovative.
Managed to get along on it.
You can imagine you have to do that, it seems to me. And maybe we learn ways of doing it that would be better to use on the Earth, including and easier considering you have air.
Yeah. And again, you take it back to Earth. And then it helps us, lots in many ways on Earth.
So the nice thing for students today is that the universities now have exploration programs and pilot programs to try these, to try growing plants in a lunar soil simulant, or to build a machine that will keep the dust down so you can, or radiation shielding, or all these great things. Like, there are projects now for them to get involved in.
So where are we then on the technology, the science that would go, for example, to the moon, but maybe another planet as well, to actually do this? I mean, you're talking theoretical, or are you talking something that is actually in process?
Both. There are things in process for extracting water from dry dirt.
That's not easy.
You can reduce it using solar power for the heat. There's hydrogen on the moon, and you can react it with the dirt. It reduces iron oxides that are in the earth, in the lunar soil, produces H2O, which is both not only drinkable, but it's life support for the oxygen part when you split them apart, and it's repellent when you recombine them.
Yeah, well, and
so
then you can get energy in the process.
And
it creates energy.
There's water at the poles as well, and there's going to be much more work done on how you can extract it without losing it, because it's very cold places. The water extraction by reduction using hydrogen has been shown to work, including during field tests on Mauna Kea, down slope, where we had some robot rallies, and they had gear on these things, automatically taking a scoop of Mauna Kea ash and producing water from it. So this can be done. That kind of equipment is in kind of an advanced state. Can you get out aluminum? The answer is, yeah, we know how to do that. You just have to have enough energy to do it. And it goes on a lot, and there's been enough work to know everything, what's feasible and what seems to be much more difficult to do.
So okay, so you talked about dust and getting water out of it. You talked about finding hydrogen and combining it with oxygen in order to get water and energy in the process. Would any of that be useful as cargo to come back to Earth, or is its use limited to the planet on which you found it?
It seems more economical to use it where you are, in place.
Yeah. The only exceptions that people have thought about are, first, solar power from the moon, where you could have, there's a lot of real estate on the moon, and if you put out solar cells, it is around the whole moon so that it's sunny someplace all the time. You can produce a lot of electricity that could be either microwaved back to the Earth, or
can you convey energy by way of microwaves?
Yes, you can. And this guy named Dave Criswell, who lives in Houston, he's been active in this space applications business for a long time. And he and others have looked thoroughly at the problem, and it is feasible to do this. There's environmental consequences, because it's like a hot beam coming down, and there may be this energy generation might be associated with roasted birds. So there are these problems, but in principle there are potential products. Another famous one is helium-3. It's not abundant on the moon, but it's in the dirt from the solar wind. Not very abundant on the Earth. And one of the ways of doing fusion power is deuterium helium-3. And the beauty of it, it doesn't produce as much nuclear waste, and it's very efficiently converted because it makes protons, which are charged particles, to electricity. However, we can't make other fusion work yet. In fact, fusion power is always, for my entire life, and as Linda might confirm, I'm an old guy. Fusion power.
We're going to bring things together.
Commercial fusion power has always been 35 years away.
Always. It's a moving target.
That's a hard one.
Physical constant.
But can we go back to this whole notion of trying to find energy on remote planets and then deliver the energy back to Earth, where, people don't necessarily want to do renewables, or they don't have the money to do renewables, or the environment isn't right for renewables, or whatever it is. And if we had a way to get energy there without disrupting the environment and sending it back by way of microwave or some other technique, that would be fabulous. These devices, this approach could power the Earth if we could find a way to catch it and then send it without using it on a spaceship, without mass, right? Just in some other way.
But because unless you lasered it back, but even there, lasers do spread out. The closer you are, the better. That's why either a high Earth orbit solar array, which has also been looked at.
Not a planet, but our own satellite, effectively.
Our own big, they have to be big. Could beam it back to the Earth, and possibly reflect some of the sunlight as well, which can have implications for controlling global warming. And it comes back down to the Earth, or from the lunar surface. It's the thing about light. I mean, it doesn't weigh anything, so it's easier to beam it than it is. If you found a huge amount of petroleum on the moon, it would never be economical to move back.
Right.
Because it's
too hard to.
It's too hard.
You can't. The payload in a spaship is.
Whereas you can have a pipeline without walls.
A pipeline without a pipe.
With light.
That's really an interesting idea. Gee whiz, that excites my brain cells.
I know, isn't that? It says it. The other cool thing, could you pop up number 7? That's number 1.
There we go.
Number 7, yeah. So I like this because there is commerce in space. It's like refueling satellites. Instead of them being dead after their lifetime, refuel them. Cuts down on space orbital debris and all kinds of things. And I think it links. You have settlement, you have to have science. It's one of the things they'll do there, too. You need resources to maintain the base, but the resources help with science, because one of the prospecting things is you're doing geology and geochemistry, you're going to learn things. And then finally, commerce. If you're making money in space, it extends the whole space program into a new realm. Satellite technology has been pushed because we've had communication satellites, weather satellites, direct TV, and all the things that use it. And the same thing can happen on the moon, but you can't do it without science. You can't do it without money, and I think you can't do it without wanting to make money.
Sure. Well, that has an effect on people.
Yeah.
Even if you make just a little money, then it'll be the gold rush. I mean, people will want more, and they will figure that the resources are effectively unlimited, right? And although there are costs involved, the resources are unlimited. And if you can get a little, you can get a lot, and therefore you can make money.
One quick note, we're near the end here, but in Hawaii, we have programs underway to Hank Rogers that is pushing through Blue Planet Foundation the plan to establish the prototype lunar base here in Hawaii in preparation for building one on the moon. A lot of robotics, a lot of student involvement, and that is the way to do it. And you get everyone involved now. Do it here. Work out the bugs to the extent you can, and then start doing it on the moon. And you can get everybody involved. Not only all ages. It's all nationalities.
Well, it sounds like this is not necessarily the business end. The mining, the resources that can have value. It's not going to necessarily be government. It's going to be guys like the fellow who owns Tesla.
Yeah.
Private spaceships and private projects, private trips, private industrial enterprises.
Yeah. That's how it's going to happen.
And I think that's coming because there are people around who can afford to do that, who want to do that, and who may be entrepreneurial enough to actually try to make a buck at it.
Yeah.
Very exciting.
Yeah, it's exciting times. I think things are going to change in the next few years. I think we'll see some real action along.
But what would really hit the bell on this is it would be some periodic elements table. I mean, some periodic element, is that the right way to put it? Some kind of element out there that is rare, short supply here on Earth. Or a compound of some kind, who knows what, but something that is in short supply on Earth. And that you don't need much of it to have high value.
Yeah.
And then put it back on a spaceship, have the spaceship return, and sell that sucker in a marketplace somewhere. Yeah.
That is what we need. People have looked at platinum group elements for that, and those are in short supply, and also have been off and on in countries that don't always behave well. So getting it from space, and there's a big supply of it, but there's a big engineering problem of extracting these things that are in part per million range from a big chunk of iron. But you know, if the cost went up enough because we used up all those available supplies on the Earth, or getting close to it, then you could get them from space.
It's like oil, you know, it's the same. It's a commodity, and that'll affect the price.
And what you need is a infrastructure development. And that's where the private sector can play a role, governments can play a role to get things going, and international base on the moon with appropriate treaties in place. So, So,
I mean, you're talking 10, 20 years away, aren't you?
Yeah.
Anyway.
Yeah.
So what do you think, Linda? I mean, where does this fit? Put this in perspective, because we're almost out of time.
We have some really creative people who are working on it, and we want the young people with creativity to work on this too.
Yeah, but you're right. I mean, it expands your thinking, expands your vision, your mind, to think that these planets can be, you know, I don't want to say a colony, but you know, an extension of the Earth.
Yes, like another continent.
Another continent, and you can bring things back and maybe even use them in our daily lives, use them in our manufacturing.
Yeah.
I guess one last question, though, is some of these elements, compounds, whatever, would be dangerous. Okay, and assuming for a moment that it's the industrial magnates who go up there, have the money, invest the money, you know, in the infrastructure that you're talking about, how do we prevent them from bringing bad things back, bad things that are bad for our environment, that are poisonous, you know, antigens of some kind, or dangerous weapons that can be weaponized? How do you prevent them from bringing? Are there things like that you would want to stop, and how would you stop them?
Not that I know of for the moon. Mars, it depends on how advanced its biology became, which maybe not. But you never know what could be there. So we do have to be careful.
Yeah.
NASA at least, but I think other space agencies have a Planetary Protection program, which protects those planets from, we have to decontaminate things when you land on them, and will protect the Earth. Not everybody will do it. I mean, you know, there's a lot of environmental disasters that have been done.
That's true. That's a part of the species, isn't it? To despoil our own environment, to despoil our nest, so to speak.
Let's hope we learn from our mistakes.
Hopefully.
Yeah,
let's be smart.
Yeah.
Let's get smart. Yeah. This is an opportunity to get smart.
I mean, built into it could be, we have to be smart about it. And that's why I think, because in it's a hostile environment. It's dangerous on the moon, there's no air. And why not be really careful from the start? And I think if it's done, it may have to be done right.
Yeah. Well, let's leave it there. Jeff Taylor and Linda Martell from HIGP and SOS, thank you so much for coming down. My mind is expanding. Yeah, thank you.
Thank you.
Thanks,
Next
Jay.
time soon, right?
Yep.
Okay.